Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to the subject Electromagnetic Field Theory. In this subject, we are now with chapter number 12 and the chapter title is Guided Waves. In the guided waves, we started first of all the understanding of what exactly the multi-conductor transmission lines are there. So we have seen the two-wire transmission line, the coaxial transmission line, the strip lines and the micro strip lines. So based on to the understandings of the two-wire transmission line, we solved problem number 1. For the coaxial transmission line, in the previous video, we solved problem number 2 for multi-conductor transmission line. Now it's the time to take one problem based on to the multi-conductor transmission line that we have understood strip line, which is having the wave propagation of TEM type, the transverse electromagnetic type. So we have seen the formulae there for the different kind of parameters that give us the transmission through this particular strip line. So using this formulae, we proceed. So problem statement is with us. A strip line has a distance of 0.3175 centimeter between the ground planes. If the diameter of the equivalent circular conductor is 0.0539 centimeter, determine the characteristic impedance and velocity of propagation if the dielectric constant is 2.32 for the strip line material. So in this particular problem statement, the given data for the strip line transmission line is with us. Hence, the distance is given, that is 0.3175. So this distance of separation between the ground planes is there actually. So we can have this particular parameter useful to determine the values asked. So if the diameter of equivalent circular conductor is 0.0539 centimeter, determine characteristic impedance and velocity of propagation for the dielectric constant, this one. So we know that the strip line is actually a modification from coaxial cable. In the coaxial cable, the central conductor used to have the circular cross section. So we have in the terms of strip lines, that one we have the rectangular cross section. So that information is given to us. So using the formulae, while we switch from the conversion from coaxial cable to the strip line, we first of all mention small b, that is given to us. So it is 0.3175 in centimeters. So this becomes 0.3175 into 10 raised to the power minus 2 meters. Small d parameter is also known to us from this statement. So it is 0.0539 centimeters. So we can mention 0.0539 into 10 raised to the power minus 2 meters, and the relative permittivity of the medium is given to us, that is 2.32 here. So as we require characteristic impedance, the characteristic impedance formula can be denoted by Z0. So it is given 60 upon under root epsilon r, ln of it is 4b divided by pi d. So substituting the values here, so this becomes 60 upon under root, here we have 2.32, ln of, here the numerator will be 4 into 0.3175 divided by pi into 0.0539. So we have substituted all the values to obtain Z0. So Z0, the characteristic impedance, we obtain with the value that is 79.38 ohms here. Now the second parameter that is required to be calculated into this problem statement. So characteristic impedance is now covered. We require velocity of propagation. So to determine the velocity of propagation, we use the formula that V, denoting the velocity of propagation, is given by small c divided by under root epsilon r. So here small c is the velocity of electromagnetic wave into the free space or air, that is having the value 3 into 10 raised to the power 8 meter per second, the standard value. So it shall be divided by under root, we substitute epsilon here, it will be 2.32. So this results into the value of velocity of propagation v given by 1.97 into 10 raised to power 8. So it should be again into meter per second for the velocity. So with this particular determination of value v, we have solved both the parameters that were asked into the problem theory. I hope the understanding and the introduction to the strip line is quite enough. So we shall proceed to get solve the next problem for the multi-conductor transmission line, that is the last transmission line that we have taken into the previous video, that is the microstrip line. So in the next video we shall see the problem based on to the microstrip line. For getting such more topics and understandings of this subject electromagnetic field theory, you can subscribe to Ekeeda channel. Thank you.